To start, let me tell you that we have here a dataset with mall customers with a few features about these customers. And our goal here is to segment these clients to give useful insights to the marketing team, so they can prepare some marketing campaigns or adapt some products to each segment. And let's start by taking a look at our data. So let's import our libraries. So to start, this data frame is available in the link from the Kaggle. I will leave in the description. And let's do pd.read CSV to import our CSV, and then the name of the CSV, customers.csv, and let's set an index. With the customer ID column. Now let's see the head of our data set, and as you can see, we have customer ID, the gender, age, annual income, and spending score. So this is the data from our data set. And now statistics about our data set. Describe, let's use describe to take a look at it. So we have 200 instance. Okay, no negative values, it's okay. In this column we don't have more than 100. Max age is 70. Okay, I think there is nothing to do here. So let's see if we have null values. No, we don't have null values, so that's great. We don't need to drop any instance. Now, one thing that we need to do is to drop the gender. And why? Because we need to work with numerical data. So columns, let's drop gender. And don't forget, in place equals to true. In place, it's an N. Yeah. Okay, now let's take a look at the distribution of our data. It is important to see if we need to do any transformation. I don't think so. Age. Yeah, we don't have a great skewness, so let's do the same for the other columns. For annual income, okay, it's not very skewed. It's okay as well, so this won't be very significant for our model here, so there is no problem. So, and this one is great. Yeah. Okay, that's perfect. So now let's talk about the k-means clustering. Let me tell you a few details about this so you can understand it. The k-means is one of the most known algorithms to find clusters, works with large datasets while being very fast and efficient. And this technique was developed in 1957. It is a centroid-based clustering algorithm. It tries to maximize the intra-cluster similarity and minimize the inter-cluster similarity. To start, we need to set the number of clusters for the k-means algorithm, and how many clusters do we want. So we don't usually know this, but there is a way to try to find the optimal number of clusters, and clusters are usually represented by k. So, and how this works? The algorithm will try to randomly select k centers, a number of clusters. These are called centroids. Then it will assign each instance to the closest centroid and calculate the centroids for each cluster form. Then it returns to the step 2, which is assign each instance to the closest centroid, calculate again the centroids, and keeps doing this until the centroids don't move anymore. And so you can understand better what this means, I will show you this video. In this video you are able to see that we define the centroids, then it starts moving and reassigning the instance until it reaches a stable solution. The centroid doesn't move anymore. We can see another example. We calculate random centroids, they start moving, and then it stops moving. And that's basically what we'll be doing here. So I will leave here an information. You will be able to find this Jupyter notebook in the GitHub repository. I will leave this. And let's start by finding our clusters, having in mind the annual income and spending score. Now, let's define a new data frame with these variables. You can calculate these with whatever variables you want. So for this purpose, I will start with these two, and then we'll do another one for all the variables, and I will teach you how can you do a 3D plot the frame. So it's more easy if I copy this one. Annual income. If you want to practice, you can try to change the names of these columns, because there is no need to have this huge name. So, and this is our data set. And let's visualize our data. We can choose a kind of scatter plot. And then let's define our x, which is the annual income. Then define y, which is the spending score. And then we can do a fixed size equals to, let's say, 10 by 7. Now PLT show. We are ready. So this is our data, and you probably are able to see how many clusters you may have here. How many clusters do you think we have here? Okay, let's use a way to find these clusters, which is with the elbow method. This is one of the limitations for this kind of problems. We need to set the initial number of clusters, and most of the times we don't know, we have no idea. And to try to understand that, we can use the elbow method to find it. The elbow method is built with the inertia from each number of clusters. And the more clusters we have, the closest each instance will be to the centroid. So we have more centroids, so each point will be closer to the centroid, right? Which can be represented by inertia. And that's what we are plotting here, which will be decreasing while the number of clusters increases. Let's compute that. So let's build a dictionary for the sum of square distance. And then let's do a loop. For each k in range of 1 to 10, for example. This is the number of clusters we will be doing this. Let's use km for k-means equals to, and now we call the k-means from the scikit-learn library and define the n clusters equals to k, and then we'll use the init, which is an initialization method for the centroids, and in this case we'll use the k-means ++, which is perhaps the best way to initialize our clusters. I will leave also a documentation about this so you can understand better. And then the number of max iterations, let's say 1000. So, and now we will fit our k-means into our data frame. And then let's and now let's save our inertia for each k-means. Okay, k-means is not defined. Of course it's not. It's missing an S. Clusters. So many errors. What's going on? Alright, now it is ready. Okay, now let's do a plot to visualize our elbow method. So SNS, let's do a point plot, and for our X we will use a list. For our, let me copy this, key values, and then let's do the same for our Y, which is equals to a list for the sum of square distance for the values. Okay, and now let me just plot labels. Okay, here is our plot to display the elbow method, and if we look at the elbow in this plot, we are able to observe that inertia stops decreasing significantly at k equals 5. After that point, usually more clusters doesn't give you much more useful information. But as a data scientist, you will need to interpret the business context and the marketing objects. Does it make sense to have more clusters? Does it make sense to have fewer clusters? But we'll stick with this one. Let's continue. Because there is also another way to help us defining the optimal k, the number of clusters. I'll use it at the end of this as a metric to evaluate our decision. So for now, let's keep k equals to 5. So now let's do the k-means clustering. Now that we find out the optimal k, the k-means is very sensitive to the initial positions of the centroids as well as the existence of outliers. So far we can tell that we don't have outliers from the distribution plots, but there is a way that k-means was improved for the initial position of the seeds, which was through the k-means ++ initialization. I'll leave a link below with the article so you can read more about it. Let's start by creating the model for our k-means with n clusters equals to 5, and then the init will use the k-means ++, it's not this, and the max number of iterations equals to 1000. And then we use model.fit with the dataset that we want. And again, I'm always forgetting the S in both places. And now, alright. And now, what can we do with this? So we can print, for example, our labels, which are the clusters. So for that we use model.labels underscore, and these are the labels from our model. And we can also print our centroids with model.cluster centers. So, and for that we can also do the centroids and assign it to the model.cluster centers. So we can save our centroids, and now we need to assign our clusters, our labels, to a new dataset. For that, let's do def1 cluster equals to def1.copy, and then def1 cluster, and now let's create a column called clusters or cluster with model.fit predict def1. Okay, and now we can visualize our dataset head. So and now we have annual income, spending score, and the cluster which instance is assigned to. Now to visualize our cluster, let's do the visualization. Let's first create the colors that we will be using. You can use any colors you want. So let's, for example, red, blue, black, gold, and it can be navy. So, and now we will assign to a new column these colors. And for that we'll use the map function. So def1 cluster, and then assign to the cluster column dot map, and now lambda p for colors p, and this should do the work. What's wrong here? Color is not defined. Okay, yeah, of course. And now let's plot our clusters and centroids. To do that, let's plot a figure, fixed size, equals to 2010. Now LT, let's do a scatter plot for def1. Let's call the annual income column or values. Let's do the same for def1 and spending score values. And now let's assign the colors that we defined. Let's also do a scatter plot for the centroids. So let's define the X centroid and then the Y can be done by 1. And let's assign a color for the centroids. It should be different from the ones that we already use. Can be green, we didn't use green. And the size of these dots, let's put this value, for example. Something is wrong here, it is one. Okay, now penalty show, and we should be able to see. Yeah, it's missing an S. I don't know what's going on today. Missing a lot of S's. And here is our 5 clusters with the 5 centroids, with different colors assigned to each other. We already did the clustering. Now we need to evaluate our clustering. And as I said earlier, we can use the silhouette score. And the silhouette score varies between -1 and 1. And the score closer to +1 means that the instances are well inside its own clusters. And closer to -1, it means that instances have been assigned to the wrong clusters. So let's see how can we do this. So usually the silhouette score is more precise than the elbow method, however it requires a lot more of computer power. So we need to define a labels variable, and that's easy. We just need to call the model.labels_, and after that we will use the silhouette score and call our df and our labels. And we had a score of 0.55. Now we need to compute each silhouette score for each k. And after that we will be able to see if we choose and for that we will use code similar to the elbow method. Let's define a dictionary to store our silhouette scores, and for each k in range from 2 to 8, for example, we will compute km equals to the k-means with n cluster equals to k, the init equals to k-means, I won't wrong this one again, and max iterations equals to 1000. Now km.fit with df1 and silhouette of k equals to silhouette score of df1 and km.labels. Okay, another error. Yeah, I didn't miss initialization but missed the clusters. Silhouette is not defined, so this is wrong. Okay, now it is. So let's grab the code from here. It is pretty much the same, we just need to change a few things. So we will need this dictionary, the silhouette, and now we will need the silhouette scores, number of clusters, and here is silhouette scores for each k. So as you can see, the best silhouette score is really 5k, which confirms that we choose the best k. Now let's do a fast k-means. So I can show you how can we plot a 3D visualization to see several features instead of only 2. So, and for that let's use the client segmentation. Let's use node. Let's build with all the three features. And now we need to define the df2 equals to df dot copy, and we have our data frame here. And now let's do the same as we did here. Let's find out if there is any difference between the number of k, and now we need to change this to df2, and it's pretty much the same thing. Yeah, I think it's 5, 6. Yeah, from 5 to 6. Let's try 6 this time just to see it different, because you need to choose the elbow where the inertia stops decreasing significantly. So yeah, so as you see, it is a relative choice. So let's build a model 2 equals to k-means and clusters equals to 6, then init equals to k-means plus plus again, iteration equals to 1000, and then model 2 dot fit df2. Okay, again, dude, I don't know what's happening today. Okay, now we need to compute or create the column for the cluster, and then model 2 dot fit predict df2, and then let's see how the dataset is. Okay, that's fine, it is okay, and let's compute the 3D visualization. So let's start by defining the labels for this model. Model 2 dot labels underscore, and now the centroid dot cluster centers. Yeah, that's it. So let's start with defining our df2 labels, which is equals to our labels, and then let's set a trace and call the go dot scatter 3D. It's our 3D graph. And now, oops, let's say that x is assigned to df age. We need to set each one of it, x, y, and z. Y is and now let's set up the markers, which will be a dictionary with color equals to df assigned to the df label. We'll define the color. Next we can define the size equals to, let's say, 5, and then let's define a line which is also equals to a dictionary of color assigned to df2 label white set to 12. We can even define also an opacity for in order to be able to see overlaps between instances, which is useful when you have a lot of data points. And now I can close this. Why? And now our data, which will be assigned to the trace. And now the layout, we'll use again Go layout. This one is capital R. Title assigned to, let's say, clusters, and then a scene which will be assigned to another dictionary, a lot of dictionaries here, for the x-axis, which is assigned to a dictionary of title equals to age, and now another one for the y-axis with a dictionary with a title of annual income, and another one for the z-axis with a dictionary for the title assigned to the spending score. Okay, I think we are ready to finish this. And now our figure will be a go.figure with data equals to the data that we define and a layout assigned to the layout that we define. Now py.offline.iplot fig to compute the fig, and now plt show. And I think I'm ready. White is missing a D. This is marker, not markers. Okay, and voila, this is our 3D plot. And here we can see clearly that our data is divided into clusters within 3 dimensions. So we can see it's split by age, we can see it's split by annual income and also spending score. And this type of graphs or plots are very useful to understand better the clusters when we have more than 2 features. So as a challenge, if you are doing this project, try to compute the silhouette score for each k and make a plot to visualize if the k equals to 6 was the best choice. And if you want, you can also use the k-means to segment the mall customers by age and spending score. If you are new here, consider subscribing and give a thumbs up, that helps a lot the channel. I will leave a link below with the playlists for other tutorials and machine learning projects, so keep practicing and you soon will be rocking data science.